Hello everyone, welcome to the second day of our SCNXT 2021 conference. Hope you all had some good pointers to take back home yesterday, and we are sure that you are going to have a great time today as well.
Let me introduce our next speaker, Christian, a senior Java developer who is passionate about backend technologies. In the next session, Christian will demonstrate how to build highly concurrent, distributed, and resilient message-driven applications for Java and Scala with the Akka framework.
Hello, my name is Cristian Curta, and today I will talk about the Akka toolkit and tell you guys about the benefits that it can bring to developing performance software. Here we have the index for today. I will start off with laying down some basic concepts about reactive programming and the actor model, which are the main parts of Akka, and then get into working with Akka actors, streams, and present some advantages, disadvantages at the end. Short introduction about me. I am Cristian Curta, and I've been working with Globant since the acquisition of our Romanian TDC. I've been working with Java professionally for about 8 years now, and started playing around with it around 10 years ago now. Also, other than coding, I love sports, and I'm a very competitive person. I go to the gym 4 to 5 times a week, doing different exercises, such as weightlifting, cycling, swimming, and also I enjoy playing computer games as well, and I'm a global elite in CSGO. All right, let's kick it off. Starting off with a part of trivia. Where does the name Akka come from? It comes from a goddess in the Nordic mythology, and represents all the wisdom and beauty in the world. In software development, the official definition of Akka is that it's a toolkit and runtime for building highly concurrent, distributed, and fault-tolerant event-driven applications on the JVM. Here we have a couple of quotes from Jonas Bonnet, which is the CEO and founder of Lightband. Lightband is the company behind Akka. He says that it gives developers a unified way to build scalable and fault-tolerant software that can scale up on multi-core systems and scale out in distributed computing environments. Akka also makes it possible to build software systems with reliability and high performance without sacrificing developer joy and productivity. Here we have a screenshot from their official website with a list of big customers which are actually using Akka in production. Here we can see that it's proven to work in very important businesses such as British Petroleum, ING, PayPal, Tesla, and so on. Okay, time to lay down some concepts about reactive systems. Reactive systems are based on the Reactive Manifesto, which was written in 2014, and systems built as reactive systems are more flexible, loosely coupled, and scalable. This makes them easier to develop and amenable to change. And they are significantly more tolerant of failure and are highly responsive, giving users effective interactive feedback. The 4 main characteristics of a reactive system are responsive, resilient, elastic, and message-driven. Responsive means that the system responds in a timely manner, if at all possible, and responsive systems focus on providing rapid and consistent response times, so they deliver a consistent quality of services. Resilient refers to handling failures appropriately. Failures are contained within each component, isolating components from each other and thereby ensuring that parts of the system can fail and recover without compromising the system as a whole. Elastic means that the system is able to handle fluctuations in load, and they can react to changes in input rate by increasing or decreasing the resources allocated to service these inputs. Message-driven, reactive systems rely on asynchronous communication. This establishes a boundary between components and ensures loose coupling, isolation, location transparency, and provides the means to delegate errors as messages. Now, let's talk about the actor model. It originated in 1973, and it's attributed to Hewitt, Bishop, and Steiger's publication. And it refers to the mathematical model of concurrent computation, which treats the actor as a universal primitive of concurrent computation. Now, in the actor model, an application is broken up into these small units of execution called actors. These actors encapsulate the behavior and state part of an application. Now, this sounds very much like an object in a standard object-oriented design, which is true. However, what distinguishes an actor from a standard object is the way it communicates. Actors never interact directly with each other and instead communicate via messages. The behavior of an actor is primarily defined by how it handles the messages that are received. Since the state of an actor is isolated from the rest of the system, an actor never has to worry about synchronization issues, such as thread locking, when modifying its state. Introducing Akka actors. All right, similar to objects in Java, as I said, the actor encapsulates the state and part of application logic. The interaction is based on asynchronous messages. Each actor has a unique address and a mailbox in which other actors can deliver messages. Now we can see that shared mutable state is the cause of many concurrency problems. Akka actors solve this problem by processing a single message at a time and transparently handling memory visibility when the actor executes on different threads over time. Many threads can hold an actor F and send messages to it concurrently, yet the actor will process them in a linear fashion. Accessing or mutating the internal state of an actor is fully thread safe, since this is protected by the actor model. Also, they are extremely lightweight. They are just standard objects that only consume a few hundred bytes each. So the only constraint in number of actors is the amount of memory they can consume. This means that a single application can easily create up to millions of actors. Communicating with an actor. All communication with an actor is done through asynchronous message passing. This is what makes actors reactive. An actor doesn't do anything unless it's been told to do something, and you tell it to do something by sending the message. Sending a message asynchronously means that the sender does not. Instead, the sender hands the message off by putting it in the recipient's mailbox, and is then free to do something more important than waiting for the recipient to react to it. In the code, we do not access the mailbox directly. We just send the message to the actor ref, which then puts it in the actor's mailbox. In the mailbox, all messages sit there until processed in a linear fashion. Working with concurrency. This is a thing that can cause a lot of pain, a lot of work, working by implementing your own concurrency. Now, Java provides a lot of tools to help you handle concurrency, but most of the cases you have to write your own threads, write your own futures, worry about synchronized blocks, immutable objects, and so on. This can create a lot of work and a lot of breaking cases. A lot of bugs can appear and so on. But using Akka actors and the actor model, we don't have to worry directly about concurrency, as the actor model handles everything behind the scenes. Let's get to main actions that we can do with an actor. We can create actors, we can send messages to other actors. The actor can become or unbecome, which means that it changes the behavior for handling the next message. And it can supervise, which means managing another actor's failure. All right, let's get down to the code. In order to work with Akka actors, in Java at least, you need to add this dependency, and then you're good to go. Let's go down to creating an actor. So in this case, we have a Akka dog. In order to make it an actor, we need to extend the abstract actor class and implement the createReceive method. The createReceive method basically instructs the actor how to process the messages from its mailbox. Here you can see that if we match on do something, this means that if we get a message of the do something type, then call this method. If you get this one, then call this method, and so on. In our case, we have a match only by message type, but if needed, we can also match on exact value by using the match equals method. All right, so as I've mentioned, here are the message types and here are the actions. Then we have some basic state of the actor, and here we have the methods. Here we have the message types. Do something, stop, and get current activity. These are blank, they don't have any code, they are just for distinguishing message types for our case. This one just has one action, so we can pass it on when giving it this command. All right, and next up, we have the actual implementations of the previous methods. So on do something, we change the state and we print the action. Then on get activity, we just print what the dog is currently doing in case it's doing something. And on stop, we stop what we are doing and we print that information. All right. How do we get the actor to work? Well, first off, we create the actor system. And next up, we create the actor reference. Oh, it's a typo. All right, actor off, props, which is the factory. We're creating actors. Here we pass it the actor and a name. This can be used if you want to get the reference from the actor system context at a later point. Okay. Now let's instruct the dog to do something. We do it by telling, by the method tell. Next, the first parameter is the object that we want to send in as a message. So then we'll have all right. And we have so we have instructed the dog to start running. The second parameter is the sender. In our case, we have no sender from exterior. We just want to instruct the dog like this. And if we run it, you can see that the actor started running. All right. Let's add in some more commands as well, such as get current activity. And also let's tell it to stop. All right, let's run this. Okay, and you can see the sequence of execution. Okay, now the third main action that an actor can do is the become unbecome. How do we handle that? Well, it's more or less similar to declaring a normal actor, but it can have multiple receive functionalities. So here you can see that for the normal actor, we just have this simple receive. But if we want it to have multiple functionalities, we can declare multiple receives. In the constructor, we create a receive builder. We create a receive object for each needed implementation. And in the original create receive, we become a good dog or a bad dog according to the request message. All right, let's get back to the presentation. Okay, now Akka actors hierarchy. The real power of the actor model is actor hierarchies. An actor hierarchy is when a parent actor creates and supervises child actors. This structure helps avoiding cascading failures that can take down an entire system by isolating and supervising child nodes. Creating child actors is very similar to creating top-level actors. The only difference is the context where the child actors are created in. The actor context can be thought of as where in the actor hierarchy an actor lives. The reason actor hierarchies are so powerful is that they provide a way to build systems which are fault-tolerant and self-healing. This can be done by isolating the errors to child actors and monitoring those actors for failures. As people working with software, we all know that failure is pretty much inevitable. But as good software developers, we need to always prepare for the worst, such that we can turn any situation into this one. So whenever the application is burning around us, we can use the hierarchy model to handle these failures appropriately and be able to relax, like the dog in this image. Now, the way actors deal with failure is through supervision. These are the 4 main supervisor strategies. The default supervisor strategy for an exception is to restart the actor, but this one can be overridden to define a different behavior. Resuming and restarting might seem to be the same, however, there is one key difference. When an actor is restarted, a new instance of the actor is created, which resets its state. If an actor is resumed, the actor state is maintained, and with both strategies, the messages that cause the fault is lost, but the actor does not lose any of the other messages waiting in the mailbox. Besides resume and restart, other possible actions are either to stop the actor or to escalate the exception high up the hierarchy. Let's show a quick example. All right, so we started off with one dog. Let's create a kennel. A kennel is also an actor. The actor has a create receive method. On match, for the make dogs run message type, it will make all the dogs run, and on stop, it will make all the dogs stop. Now, in this example, the hierarchy is created in the constructor. Here, when we instantiate the Akka kennel, we are creating in the context of the kennel 5 Akka dogs. All right, and here we have the methods. When we make the dogs run, for all of the children, we tell them to run, and the same with stop. So let's interact with it. Right. We instantiate the instantiate the reference to the kennel, and it's an actor even though it contains multiple actors, so we communicate with it in the same way. So we take the object and we tell it to make all the dogs run. And then let's also tell them to stop. Let's comment this out for now. And let's run it. And you can see it started running and it stopped running all the actors. All right. Now, in the kennel, as I've said, we can also implement a supervisor strategy. Now, the supervisor strategy can call the default ones, which are restart, resume, stop, escalate, or we can also modify them, update them to our need. So we have full control over the failure of the child actors. All right. Next up, we've talked about actors. Let's also talk about streams. The word stream basically means a steady flow of something. And in our case, a steady flow of data. And it's basically a sequence of data with an unknown size, which needs to be processed. How does processing streams work in Akka? Well, Akka stream is actually a model built on top of Akka actors. It means that there are underlying actors that are actually working in transferring the data. It's a library to process and transfer the sequence of elements, which is non-blocking. And that means that a certain operation does not hinder the progress of the calling thread. It provides also easy-to-use APIs to create streams that leverage the power of the Akka toolkit without explicitly defining actor behaviors and messages. That means a relief from handling the actors yourself. That also means that we can focus on logic rather than focusing on how to manage actors, and that can be more productive. Okay, let's get into some definitions for the Akka stream elements. So first up, we have the source, which is the entry point of the stream. It only has one output point, and it can receive data from files, databases, message queues, collections, etc. And we can consider the source as the producer, which ingests the data into the stream. Now, the sink is the exit point of the stream. So it only has one input, and the processed data gets thrown into it. Between the source and the sink, we can also add in some flows. What is a flow? A flow is a processing step within the stream. This one has one input and one output, and it can apply transformations of the messages that pass through it. In Akka, chaining all three of them is defined as a runnable graph, so that the stream of data produced by the source can thus get serially through different processing flows before it reaches the sink. All communication of data, of course, is done through the actor model behind the scenes, such that the characteristics of a reactive system are fulfilled. Let's talk a bit about back pressure. Back pressure often occurs in reactive systems. This occurs when sources produce a lot more data at a faster rate, faster than the consumers can process them. This means that they get slow, they cannot process them in a timely manner. But in order to have a reactive system, we need to balance it out. So we need the consumers to be able to alert the producers that they need to slow down. In Akka, the back pressure problem is handled by the actor model, because the components communicate with each other through async messages. And our luck is that this is everything is done under the hood, applied automatically, So we don't really have to worry about it. Now, let's get to the list of pros. We've gone through the details. We've seen that Akka fully implements the reactive manifesto. It's extremely fast. It can process up to 50 million messages per second. Also, it is very lightweight and scalable. We can spawn up to 2.5 million actors per gigabyte RAM. And also, the documentation is great. It's easy to follow. It has a lot of code examples and a lot of descriptions for the APIs. And also, the examples are both in Java and Scala. As a list of cons, though, once you learn the basics, the learning curve is a bit steep. And that means that development team needs to invest a bit of time into learning Akka. But after learning, the outcome is really great. I mean, once you get to learn all of the basic concepts and how to apply them, you can fully enjoy the power that Akka brings to the table. It also provokes the team to adopt a new style of thinking instead of the classic software development. But all in all, I think that the advantages that Akka brings are far bigger than the disadvantages. And I recommend you guys to try this out. This was my presentation for today. I hope I got you guys interested in it. Thanks for your time, and enjoy the next presentation. Stay tuned. Bye.
That was a very good session, right, Ashirwad?
Yes, I now have a much more clear understanding of how and what Akka framework is. And I think I can now leverage this knowledge anywhere if need arises. So Bogdan, what do we have next for our knowledge explorers, our wonderful audience?
Next session is about the Go language, its strengths and its advantages. And for this, please welcome a highly experienced professional, Andrei, who is a technical director from Minsk TDC.
Hello, my topic is the future of Go programming language. Today we are going to discuss Go strengths, compare it with other programming languages, analyze trends in labor market as well, and we'll try to predict Go future. I'm Andrei Pushkin. I'm technical director at Globant, based in Belarus, Minsk, working more than 2 decades in IT, working from Java developer to architect. Now I'm technical director. Let's look at Go from applicability, from the use point of view. I identified several spheres of application, like system programming, development of databases, writing backends or microservices, microservice orchestration, and data science, and selected several popular programming languages. On this table, you can see green cells, which means that the language has a proven track record of commercial use, while amber means that it's rarely used for this sphere, and red is the use is not typical at all. So let's look at Go applicability and compare it, for example, with Java and other languages. system programming. Go has proven track record. Like everybody knows Docker or Terraform. Yeah, for sure, Go can be used and already used for system programming. Comparing, if we compare it with Java is not usually, is not typical and not used at all for that. Yeah, same with many other fields. Databases. In Go, there are databases written already, commercial, widely used databases. I don't know, probably there exist, but I don't know many examples of that in JavaScript, C# or Python. As for writing microservices or backends, yeah, Go is also used. There are already well-known companies that use Go for building their APIs for their backends. But the same I can say about Java. Java is typically used as well for writing microservices, which I cannot say about C or C++. If you deploy application in clouds, C is not a language to go there. Speaking of microservice orchestration tools and instruments that require to handle a lot of data and should provide great performance, and Java is not case for that. However, Go is used there in this application. Everybody knows Kubernetes or Istio Service Mesh. You can see it can be used here. And one other thing I want to mention, that for data science, for processing of big data and machine learning, Go is also has its use. Same I can say about Java, but looking at the entire table, you can see that Go is one of the leaders in terms of the number of green cells in this table. So the conclusion is that Go is very multi how to say it, multifunctional in this regard. It has a lot of applications. It can be used for writing almost any piece of software. To summarize it, to simplify it, you can see that Go lies on the intersection of two application areas for system programming and backend development, microservice development. So for other languages, not that they both can be that they can be used in both areas, but Go and Rust languages, I will also mention Rust again, but the main focus of today's talk is Go programming language. Let's move on. Let's look from different perspective, from the perspective of features, of language features or syntax features. Again, I a bit simplified here to avoid long list of features for each of the language, but I think it's gives you an idea. Simplicity, from my point of view, one of the important aspects, and the Go is thanks to its minimalistic syntax. It is it is quite simple. I would say Python also simple language. I don't think that Java can be considered simple because it has from one point of view it is a bit verbose. From another, it has working on Java. You have you need to deal with a lot of libraries, a lot of frameworks, and it's both a strength. But I don't think that generally Java should be treated as a simple language. Same about C and C++. I made it even red because a lot of people agree that it is one of the most most difficult to learn language, and not to learn but to code. Type safety. Type safety is a property of language to avoid errors related to incorrect usage of type or treating one type as another type. And definitely Java and C# high-level language that have an edge here. However, Go also good is better than using plain C or Python or some interpreted language, which don't have static typing. So here I made it Ember, but with adding generics they're not yet in the language, but when they will be added, I would say that we can probably treat it as green as well. Speaking of memory, speaking of memory safety, usually languages that have garbage collector are much simpler to use than C or C++ that requires explicit memory allocation and deallocation. There is also interesting language here in Rust, which don't have garbage collection, but still green here. That is because of its primary feature that provides this possibility to avoid, even without garbage collector, it avoids incorrect memory usage with the concept of value ownership. So yeah, C is definitely red here. Speaking of object-oriented features, first, why do we might need it? I think that if you develop big applications or monolith applications, object-oriented language good choice because of the concept of pretty high-level concept that object-oriented programming provides for that. First of all, class inheritance and implementation inheritance, and we do have it in Java, in C#, but not in some other languages like Go or Rust. We do have it in C++, not in C. C is not object-oriented. So that is why only Java and C# is noted here as green. Go has some object-oriented features as well as Rust, but it lacks some. I will probably mention it later. We'll get back to that. Error handling, almost the same situation. Those who accustomed to use high-level language like Java, Python, C#, JavaScript know the concept of exceptions, and it's a very useful thing and simplifies things a lot. It allows to avoid duplicating returned result values for errors. However, Go, Rust, C don't have this concept. They do have something like that for panic, for unrecoverable and possibility to recover, but it's not its style. It's usually checking the returned result is a way to go in Go and in Rust, by the way, as well. A similar concept. Speaking of multi-threading and concurrency, Go has Go routines. It has green threads. It has channels. So I would say that it is one of the strong points of Go is multi-threading and concurrency. I would say that it's much better than Java in this regard, though Java also have a lot of libraries for concurrency, for threading, but when you need to, but these concepts are on one hand, it's pretty low level. From another point of view, it is not possible. A thread in Java is essentially operating system thread. So it is not possible to create. You can create a lot of threads, but it will require a lot of resources. So I would say that for very highly concurrent applications, Go and Rust have edge here. Speaking of performance, well, I identified 3 areas: compilation speed. Go from the resources I found so far, Go is one of the best in this regard. Speaking of execution performance, startup time is important. In case you develop microservices and you deploy it in cloud, and you need to, depending on the varying load, you need to scale, upscale, and downscale the number of nodes. For example, you have a cluster of services, and you have Black Friday. You need to grow a lot. You need to spin up a lot of services. Here, the startup time is important, and Go is very good here. Rust is even better, by the way. C++ is not used for writing microservices. Java is extremely bad here. It needs a lot of time to load Java virtual machine, to load classes, to load Java runtime environment. So it's awful. It takes a lot of time for spin up and new instance. I think the same goes for .NET. As for execution, Java is not that bad here. It's better, definitely better than interpreted language like Python, JavaScript. However, Go is even better. Go, Rust, C++, yes, they may be in some regard they are more low level, but it's also provides more better performance. So to summarize, if we take 3 axes like safety, fast, and simple, then each language will be better in some regard. However, what I like about Go, it lies on the intersection of all these three aspects. It is safe, it is fast, and it is simple. Now let's analyze the popularity trends. There are different rankings among ranking of popularity of language. One of the sources of such rankings is GitHub, which provides the popularity of language in for open source. A lot of open source projects hosted on GitHub. And the GitHub tells us that Java and Go are among top compiled language. I deliberately only put compiled language in this here because there are a lot of interpreted language that also have high ranking like Python, JavaScript, but let's focus only on compiled languages here. So as I said, Java and Go are ahead of C, C++, and C# in open source. Stack Overflow, another interesting source of information. They publish each year very detailed analysis of different technologies. And first of compiled language there in the first on the top are Java and C#. However, they have negative trend. As on the contrary, Go, Kotlin, and Rust have positive trend. So probably we will see them higher, closer to the top. Another interesting aspect that Stack Overflow also identifies is which technologies are the most loved and the most wanted. And the most loved this year was Rust, and the most wanted are Rust and Go. Also, Stack Overflow says that Go are among the top paying languages in the same on the same band as Scala and Rust, while arguably more complex languages like C++, Java, C# are in another band. In if we trust Stack Overflow. Yeah, another index is TEOB, which shows that Go is also among top trendy languages. Those who are interested, I have a link for very detailed Stack Overflow investigation of that. Also, my own investigation in Globant shows that Go is a language with very high unsatisfied demand. Let's look at the chart, top right chart. Agent request ratio. What it means. When some business work with Globant, they create requests for developers in different technologies. If request is not satisfied, it becomes aging. Most requests are satisfied within first days. There are requests that not satisfied within some time, and they are aging requests. For many technologies, for most of the technologies, about only 1/3 of requests not satisfied within 10 days. But it is not the case for Go. More than a half of Go requests not satisfied within 10 days. Why is it so? Let's look at another chart in the bottom left. As you can see, this chart shows the size of talent pool and size of pipeline or candidates that we consider for some position. So as you can see, the talent pool for Go developers is 0 right now. So all Go developers that we have in company already have assignment. So it is not easy to satisfy some request. We need to consider the pipeline, the candidates, the external candidates, but the pipeline is not big. Let's look at the bottom right chart. This is number of candidates we have per request, and usually we have 5 candidates or so, a bit less for Java, which a mark of a demand. But as for Go developer, we have less than 1 developer candidate per request. So definitely we need more. We need to have more Go developers. So the demand is not satisfied. So let's summarize. Which strengths does Go have? From developer perspective, it is quite simple and safe in terms of syntax. It has great development community, a lot of libraries, frameworks, tools, and it is well paid. It is an excellent choice for microservices. It is mature and very performant language. What is Go future? Go. I think that Go share will continue to grow. From the trend we see, it is pretty safe to forecast that the trends will continue to grow next year and next couple years. The main competitor to Go is Rust, which has the same selling point as Go. It is also it or even outperforms in safety and speed. However, today Rust is not as mature as Go. Rust also have a track record of commercial use. It is production ready. However, Go has is much the number of success cases for Go is pretty much more. Go has simpler syntax, and maybe probably it is more practical for mainstream development, comparing it to Rust. There are more Go developers on market. Again, comparing to this competitor. Not sure how this proportion will change in future, but so far I would select Go for development of backend, and I think it's quite safe. Rust in this regard is too risky. It's difficult to find Rust developers out there. And I think that Go will continue to take share of other languages. For example, for writing microservices, Java was quite popular. But in this sphere, in this area, I think that Go will take the share of it. So does it make sense? Before I finish, I want to answer some of potential questions. Should microservice developers consider it? Definitely. Yeah, especially if performance footprint and scalability is of concern. Does it mean to rewrite some monolith written in .NET or Java to Go? I don't think so. I don't think so. Only in case you want to pick some parts of the monolith, and usually it makes sense to pull out the most loaded parts and write this as a microservices in Go. So to select Rust to Go, for example, you start new project and what to use for greenfield, or what would you like? What would you learn first? Rust to Go. It's a difficult question because they're somewhat similar, but I think that today Go is more practical. More practical because it brings less risks than choosing Rust. Who should take on the new skills? I mean, in terms of Go, Java or C++ or Python developers. I will say that for Java developers, Go will be too different. If they want, it might make sense. But generally, I think that Java is very solid with strong object-oriented concepts, and it's perfect choice for many applications and will stay the same. If you switch from Java to Go, I think that you might lack some instrument that they're accustomed to, like class inheritance or exceptions. For C++ developers, definitely it makes sense to consider for learning at least the language, because it's also fast. It has similar syntax to C, but it's not substitution. Not substitution, because, for example, for game developers, C++ is more so. Go is not substitution. As for Python developers, I would say that yes, I know cases when Python developers switched to Go, and they appreciated the static type check, the performance of Go. So in many cases it makes sense. That's pretty much it. Thank you for your attention. Have a nice day. Bye.
intrigues me to explore and learn Golang. I mean, why not learn one more language in depth?
Yes, that was super cool and interesting. Now, Ashirwad, would you like to introduce the next presenter for the AWS Cloud with Machine Learning sessions?
Yes. Our next presenter is Mukta Belorkar, who will be showcasing us the uses of AWS SageMaker in machine learning.
Also, she will be showcasing the use of AWS recognition for image and video analysis with machine learning. Without raising the curtains from any of the details, let us give the floor to Mukta.
Thank you, Ashirwad. Hello, everyone. Good evening. I hope you all are doing great. I am Mukta Belorkar from Globant India. I welcome you all for today's AWS Cloud Conference. I'm sure you guys are equally excited to learn about these offerings um, as we are to explain it. Me and my team are going to explain two new offerings by Amazon, Amazon SageMaker and Amazon Recognition. If you have any questions, you can ask in Q&A tab during the conference. My team, Nivas, Anand and Sandeep, would be happy to clarify your doubts. So let's begin with Amazon SageMaker. Amazon SageMaker is a powerful service by AWS for building, training, and deploying your machine learning models in a production-ready environment. It was released by AWS in 2017 and it has quickly gotten a lot of popularity. So let's meet my team, SageMaker team, Nivas Mane,
Hi guys, hello everyone.
Anand Golecha, and
Hi
Sandeep.
everyone.
Hi guys,
So
hello everyone.
without further ado, let's dig deep into Amazon SageMaker. Over to you, Nivas.
Hi everyone. My name is Nivas Mane and I am the senior software engineer. Today I would like to share some AWS SageMaker concept. First, I am going to present some basic information regarding AWS SageMaker. Then Anand and Sandeep share with you some real-time example. Then we would happy to answer any question you may have. Okay. So first we can go to some agenda. So what is the agenda of this AWS SageMaker? First we can give some introduction. After that, then we can see what is the AWS SageMaker, why AWS SageMaker, and how it works. Once we done this session, after then we can go through one test cases where we have one restaurant data set. In that restaurant data set, we predict some ratings with their some respective labels, and after that we can provide some reference link and demos. Okay, so go to the next slide, which is what is the AWS SageMaker. Before that, Amazon SageMaker, we can see what is the AWS. So AWS is Amazon Web Service, is a on-demand cloud platform offered by the Amazon that provides service over the internet. AWS services can be used to build, monitor, and deploy any operation type, any application in the type of the cloud. So here AWS SageMaker comes into play. So a lot of data scientists develop, train, and deploy the machine learning models in the hosted environment. But unfortunately, they did not have any facility to scale up or scale down resources when required. So AWS SageMaker solves this issue by facilitating developers to build and train the model to get production faster within minimum effort of and lower cost. So what is AWS SageMaker? So AWS SageMaker is cloud-based machine learning platform that helps users to create, design, train, tune, and deploy the machine learning models in a production-ready hosted environment. The AWS SageMaker comes with the proof of full of advantages. So we can see why AWS SageMaker. Why AWS SageMaker? Because it enhances the productivity of the machine learning project. Also, it helps to creating and managing compute instance with the least amount of time. Also, it inspect raw data and automatically create, deploy, and train the model within the complete visibility. It also reduces the cost of building machine learning models up to 70%. Also reduce the time required for a data labeling task. And also it helps to storing all ML components in one place, So here we can use Amazon S3 bucket for storing all the data component, machine learning component in a one place. And it's also highly scalable and train model faster. Okay, then we can see how SageMaker works. So if you see in the image, there are three parts. One is build, test and tune and deploy. So we can see like in detail what is do in that particular section. In the builder section, first we need to provide also we need to provide some machine learning algorithms. So there are 15 algorithm which is by provide for a training purpose. So it gives also the capability to select required server size for our notebook instance. A user can write code for creating model training jobs using the notebook instances. Also, we have also choose the optimization for any algorithm, such as necessary algorithm, such as a k-means algorithm, linear regression algorithm, logistic regression algorithm. Also, AWS SageMaker helps developer to customize machine learning instances with the Jupyter Notebook instance. Then we can move on to like next section, test and tune section. So what is this? So it is a setup of the input required libraries. So in define a few environment variables and manage them for training the models. Train and tune the model with Amazon SageMaker. So SageMaker implements hyperparameter tuning by adding a suitable combination of algorithm parameters. SageMaker also uses Amazon ES3 for storing the data and it's totally secure, safe and secure. Here, ES3 is only used for the storing and recovering data over the internet. Only the purpose here. And Amazon SageMaker uses also ECR for managing Docker containers as it is highly scalable. So here ECR helps to user to save, monitor, and deploy Docker containers. SageMaker divides the training data and store into the S3, whereas the training algorithm code is stored in the ECR. Later, Amazon SageMaker set up the cluster for the input data, then train and store it Amazon S3 itself. Suppose you want to predict limited data at a time and use Amazon SageMaker hosting services, but if you are going to get prediction for an entire data set, use Amazon SageMaker batch transform. Okay, so once train and tune is completed, then we need to deploy. So once training is done, the model can be deployed into the SageMaker endpoints. So in the endpoints, a real-time prediction is performed. Now evaluate your model and determine whether you have achieved your business logic or business goals or not. So we see the like how it works, the diagram. So we can see Amazon SageMaker model tuning and deployment diagram. So if you see in this diagram, we are getting the data from the S3 bucket. We are training and tune the data in the Amazon SageMaker ML instances. Okay. Once we are the data segregated in two parts. First part the training data, which is 80% of data, and second part is a 20% data as a we are using for a testing data. So our train and test data we can store into the S3 bucket as it is. So we can see this is the work of the Amazon SageMaker. So we can move on to like use cases of the our SageMaker session. So here is our tasty restaurants, and this restaurant has a multiple branches in the city. Okay, and based on this some labels, we are predict some ratings over here. So what label we are considering here? First is online order, book table, odds, location, restaurant type, cuisines, cost, and menu item. So these labels we are considering for predicting the ratings. On that prediction, we are then decided to where the restaurant is suitable for particular location or particular book table, and all the things we are getting to know. Okay, so for actually example, we can see in the example section in the live section. So Anand, over to you. You can continue. Thank you, guys.
Thank you, Nivas. So, hi guys, this is Anand Golicha. So, I will be explaining you the use case that Nivas has mentioned for Amazon SageMaker. So, before that, as Nivas said in earlier slide, that there are two tools. Hope you heard those, like Amazon's SageMaker Studio and the Jupyter Notebook that you will be using for this Amazon SageMaker's code. to deploy and create on the AWS. So and how it looks is nothing but on the screen. I'm using Amazon Studios to write down a code. So let's quickly jump onto our use case now. So what exactly we were trying to achieve over here is nothing but we have a restaurant which is serving in different location, and say if you wanted to open any restaurant in particular location and attack to this restricted restaurant collection. So you should be examining your previous data, like what is the probability to getting success in particular location on the basis of certain parameters, and they are nothing but these on the screen, like does that restaurants are online order or not, then does that restaurant allow you to book the table online or not, then what are the waiting votes for that restaurant, and in which location you are opening the restaurant, and then the restaurant type, like is it serving veg, non-veg and cafe, or it is casual dining. All those things taken consideration for this machine learning tool to learn on the basis of these data, and it will predict for you the rating that you will be getting for this restaurant in that particular location. So this whole process have certain process steps. So I will be going through those step by step. So this is the step where you will be importing the data. Let me show you the data first, like what exactly we were trying to analyze on. So this is the CSV which I do have, which is have predefined rating, so that your machine will be knowing that what rating comes for what data actually and for what parameters. So on the basis of that, it will start learning, and once it is ready and learned well, we can use that machine in the execution environment, and we can give it a input, and you can get the output out of that. So in the step mentioned over here is nothing but doing what we are just importing this CSV into the program, and we were trying to collect the data set out of it. So uh, uh, as you were able to see it on the screen, we just imported that CSV into the program. Then in the next step, that comes for every machine learning, that it should have some training data, and it should have some testing data and validation as well. So as we imported the CSV, we are just dividing that CSV into 2 or 3 different data sets, like one is used for training, one is used for testing, and one is for validation. So in this step we were performing that things here. So if you are able to see it, then we are just doing what we are separating the ratings, which is nothing but the target and expected output from this machine learning tool that we are mentioning over here, by segregating that column. I will explain you why we did it, because it needs this SageMaker has its own template that has to be uh, uh, provided to it to start learning on it. So uh, over here, like if as we have CSV with us, we should be using some of its data for testing and some of its data for training purpose. So as more and more data we give it to training, it will start learning more and more. So we as we have means thousands of record, we are just segregating 85% of it for training purpose, and 15% of it for testing purpose. So in this step we just mentioned about those things. And then once we divided the data well, as you can see, like a 19,760 record are for training purpose, and then for testing purpose we have kept 1744 records, and for validation 1744 as well. In the next step, what we were doing actually, we have to perform learning as we have our testing data ready, training data and validation as well. So we will be doing the learning now on. So that's what we are doing afterward. So as I said earlier, that this Amazon SageMaker needs data in some format, so that to analyze that data for the expected output, and that expected output is nothing but the target for us, and we are keeping it as a first column as required by Amazon SageMaker. So these are the nothing but the parameters which are there, which are shown you in that CSV. So and this validation, this rating column have the floating point notation. So we were keeping it as a float data type. That is with this. And then we are using some predefined libraries which are there from the Python, which is called Boto 3 and SageMaker, which we are doing to connect to S3, where we will be keeping our data, this training and validation data. And of course SageMaker is we are taking some APIs from SageMaker's its own library, those regression algorithm and all those stuff. We know like we should be using some algorithm to perform your machine learning process, which is explained by Nivas. Like there are so many algorithms, k-means, then regression, and we are using one of them, which is nothing but linear regression for particular to this use case. So I have mentioned over here that what we wanted to use out of it. And then this is the means folder which is there in the S3 bucket. I will show you in meantime uh, that where exactly we are keeping the data. So let me show you that. This is the S3 bucket we are where we are keeping our data once it is ready, the training and testing data from that CSV. So if you go inside it, we made a arrangement inside the code which will connect to this. I will tell you how. So if you look at the code, we have provided links for this that particular bucket in this format, which is required by Amazon's S3. So we are maintaining that format by this keeping this template format. And then once we are ready, of course I forgot to mention that we should be also using some authentication, that I am role to connect to that AWS. So that we have done over here uh, in this particular step. And then once the link is connected to S3, we should be running this machine learning tool so that it will train on the basis of that training data which we divided earlier, and it will keep that data into that S3 bucket. And yes, we are using some hyperparameter for better tuning and testing purpose. So that is mentioned in this particular step. These are the constant for those hyperparameters. And then once we are all ready and all set up, we are ready to run this and we are ready to allow this machine to learn on your existing data. So for this video purpose, to save our time, I already executed this because it will take 2 or 3 minutes, which will be which will waste our time during this video. So of course you will get output like this, that once you start running this, then you can use shift enter to run. And then once it is all run, you are now ready to go for what? To deploy, because we need to deploy your machine learning tool, right, to on the execution environment. And once it is in the execution environment, you can provide your inputs and you can perform your predictions out of it. So and with AWS it is very simple task, trust me. You don't have to do anything, you just have to one click and you are ready to go to deploy. So that's exactly is the code showing us over here. The one line of code is doing all the deployment for you. And then once that execution come and deployment is done, you will be ready with your sample. For here we are using sample data, which is nothing but the input that we will be using for predictions. So that I imported over here. Let me show you that this is the sample input that we wanted to predict for. And this is imported over here, just we did for earlier CSVs. And then once you run your prediction code, you will get the prediction out of it, which you are able to see it over here, that it predicted for each and every input with this rating 4.1, 4.2. and this is nothing but what is the rate of success that you will get when you serve your restaurant in particular location with tasty treat. So that's what it is showing. And as we use our data for testing purpose, I was having the rating what was expected from that particular input. So it was 4.2 for me, and what comes as an output for from this machine learning tool is nothing but 4.1, which you can say like which is closer to the 4.2. Of course, you will always not the case that you will get the exact output. It is like more and more you train your machine learning tool, it will give you a more and more closer result to your expected output. So that's how it works. So also it is also in the range of 0 to 1, where 0 is mentioning that it is not the good case, and 1 is the closer output and the exact output. So if you see over here, if you compare this 4.1 with 4.2, what comes out from the machine learning tool, it is giving you a 92% closer result out of this whole algorithm. So this is it, guys. Over to you, Mukta, for further.
Yeah, thank you, Anand. That was a very interesting presentation. I hope everybody enjoyed it, and I hope we were able to explain you better to understand it in a good way. Our next interesting topic for today is Amazon Recognition. Amazon Recognition is a cloud-based software as a service computer vision platform that was launched in 2016. It provides two API sets. You can use Amazon Recognition Image for image recognition and Amazon Recognition Video for analyzing videos. Amazon Recognition is an image recognition service that detects objects, scenes, and faces, extracts text, and identifies inappropriate content in images. Sound interesting, right? So let's meet my team for Amazon Recognition, Ankush Govind and Dhanashri Sirsat. So let's understand more about Amazon Recognition with Dhanashri and Ankush. Over to you, Dhanashri.
Hey, thanks, Mukta. Hello, guys. This is Dhanashri Sirsat from Globant India. As you can see on the screen, we will be starting with what exactly Amazon Recognition is. After that, we will have a look at few of its features, and then we will also discuss the advantages of Amazon Recognition. After that, we will have a look at the customers from wide variety of domains who are using Amazon Recognition to grow their businesses. Moving on, we will see how exactly it works with the underlying processes and overall execution flow with the help of an use case. And finally, we will end this session with a short demo where we will show you how to actually use this Amazon Recognition. I hope I'm clear with the agenda, guys. So without any further delay, let's begin with our first topic, what is Amazon Recognition. As you can see on the screen, Amazon Recognition makes it easy to add image and video analysis to your application using proven, highly scalable deep learning technology that requires no machine learning expertise to use. With Amazon Recognition, you can identify objects, people, text, scenes, activities in images and videos, as well as detect any inappropriate content. Amazon Recognition also provides highly accurate facial analysis and facial search capabilities that we can use to detect, analyze, compare faces for a wide variety of user verifications. People counting and people safety are few more use cases of it. With Amazon Recognition custom labels, we can identify objects, scenes in that image that are specific to your business needs. So let's give me an example. You can build a model to identify a user is equipped with a required safety kit or not. So these custom labels take care of identifying the hand cover, head cover, face cover for a user for you. So no machine learning experiences are required by you. You simply need to supply the image of the object or scene you want to identify, and service handles the rest. So this was the overall idea behind the concept of Amazon Recognition. Now let's just move on and discuss the various features. So the first feature of Amazon Recognition is the labels. With Amazon recognition, you can identify thousands of objects such as bike, telephone, building, and scenes, such as parking lot or beach or stadium or whatever. When analyzing a video, you can also identify specific activities like playing football, delivering a package, and so on. So the second feature here is the custom labels. For example, you can find a corporate label in a social media, identify your products on the store shelves, classify your machine parts in an assembly line, or detect any animated characters in the videos. So the third point here is the content moderation. Amazon recognition helps you to identify potentially unsafe and inappropriate content across both image and video assets and provides you with detailed labels that you can allow to accurately control what you want to allow based on your needs. So the next point here is the text detection in photos. If the image is uh, if the image is appearing differently on the neat words on the printed page, then Amazon recognition can read skewed, distorted text to capture the information such as store names, street signs, or text on the product packaging. So next feature is the face recognition and analysis. With Amazon recognition, you can easily detect if when the faces appear in the image and the videos and get attributes such as age, gender, eyes, glasses, facial hair, etc. In video, you can also measure how these attributes change over the time, such as constructing a timeline of the emotion expressed by an actor. Next point is face search and verification. Amazon recognition provides a fast and accurate face search, allowing you to identify a person in a photo or a video. Using a private repository of the face images, you can also verify or identify by analyzing a face image against the image that you have stored for comparison. Next point here is the celebrity recognition. You can quickly identify the well-known people in your video and also in the images. And the last point here is the pathing. You can capture the path of the people in the scene when using the Amazon recognition with the video files. For example, you can use a movement of an athlete during the game to identify the place for the post-game analysis. So these were some of the coolest features of the Amazon recognition. Now let's just talk about the advantages here. So the first advantage here is that you can easily integrate powerful image recognition in your mobile or desktop application. So here you eliminate the time-consuming complexity which is associated with creating the capacity for image recognition in your application with just a simple API. AWS recognition is an excellent solution for the precise and robust image recognition. Moving on, the second point here is the artificial intelligence. It is the core of the AWS recognition. This service has grown out of deep learning technology that Amazon has been working on for some time already. As a result, Amazon is continuously adding support for the new images and improving their facial analysis capacity. The precision of this information given by the Amazon recognition keeps growing and improving as the new challenges present themselves. The third point here is the image analysis that is scalable. Amazon recognition analyzes literally billions of images over a course of a day. The service provides uniform response time independently of the volume of requests for analysis that you carry out. This is to say that the latency of your request for the information remains the same whether or not you make one request or the 1,000 requests or even more. The next advantage here is the full integration with the popular components of Amazon Web Services. So the Amazon recognition is designed to work together perfectly with AWS S3 and AWS Lambda and various other popular AWS services. As far as the integration of Amazon recognition is concerned, there is not a single issue that you can face while working with it. And the last point here is the low cost. So developers can only pay for the quantity of images that they analyze and the metadata for the faces that they store. There is not a minimal requirement for the payments or the initial commitments. So this summarizes the benefits of the Amazon recognition. Now let's just see how these leading organizations worldwide are using Amazon recognition to add image and video analysis to the application. The CBS Corporation, which is a mass media company, now the US organization C-SPAN, which is also in public service, Make TV creates the technology and solutions that help for the content creation. Family Search is the largest genealogical organization in the world, and it is dedicated to connecting the families across the generations. Influential is another premier AI-powered influencer in the marketplace. Limbic is first data studio for the short-form videos. Sportograph has the natural affinity for the sports. So recognition services help them to organize these images by using the beep number with a high-speed accuracy. Pattern 89 uses the Amazon recognition to provide our customers the deep data analysis. So let's just move on to next part here and understand how it works. So the Amazon recognition basically provides two APIs. We can use Amazon recognition image for analyzing the images and Amazon recognition video for analyzing the videos. Both these APIs analyze image and videos to provide the insights that you can use in your application. We have chosen one of the use case from the safety and security domain to demonstrate it. We are going to show how a use case of a labor employee verification for authentication and authorizing him if he is equipped with all the required safety protocols. We will have to compare the user's live image captured by any camera integrated device. We have built a small application based on the microservice which is integrated with Amazon S3 and Amazon Recognition. Application consumes the APIs provided by these services. Amazon S3 is already having a test data stored in it, and this test data mainly comprises of images of the authenticated labor employees. Application retrieves the images stored in the S3 bucket and sends them to the recognition for the face comparison. If the similarity score is above the threshold value, which is configured at the application by Central Config Cloud, then it authenticates the user. Else, it just denies the entry at the facilities. The similar case has been developed to identify the PPE kit or the safety measures from the live images. If they all pass the safety protocol, it connects the AWS RDS to retrieve the employee worksheet data and provide these details in response. Next slide will depict the system architecture developed for this. As you can see, the other AWS services can be easily integrated with the AWS recognition service. As we develop this use case further, we can also integrate more services like Amazon Lambda to trigger the functionalities when the new test data is uploaded into the S3 bucket. So this design is really scalable and it seamlessly works with other services. So moving on to next slide, we can quickly go through the technology stack which can be used here. We will need an image capturing device, the UI interface with the latest UI technology. S3 bucket can be used to store the authenticated employee images. An application which is connecting dots between these services can be built by using the microservices using Java or Spring Boot technologies. Amazon Recognition SDKs, yes, of course, they are needed for calling the services. And Amazon Recognition services that will be consumed in the application. AWS RDS for storing the employee worksheet data. So that's all, folks. So enough of theory, huh? So let's quickly move on to the demo part now. Over to you, Ankush.
Thank you, Dhanashri. Thank you so much. Hello, guys. My name is Ankush Govin. I'm going to show the use case demo for that Amazon recognition. So as Dhanashri already mentioned about this use case, so by using Amazon recognition image analysis API, and there two of the functionality for comparing the face comparison, and again PPE detection, that is personal protective equipment detection API. That two functionality we are using for employee verification and their protective equipment detections. So we have developed two APIs. One is for employee verification, and second is for PPE detection. So verification is nothing but that whatever the organization is having the employee data, along with that data they have the images of that employees. So this API is going to verify those employee by providing the live capture images, and once it is get verified, it will going to uh, cross verify those images, and it will going to fetch the employee details. So here we're going to provide one of the employee image. So here we can see by looking at the logs, it is going to fetch the images from the S3 bucket. It will cross verify with the live image, which is where image we have been provided for that API. Yeah. So image has fetched from the S3 bucket, and it is get validated whatever the image we have been provided for that API. Once it is get validated, it will going to fetch the detail of that employee. So we can see here is the employee details, and along with that employee detail, we have the working shift detail of that employee. And another scenario where that will going to provide such a image, that live image, which is not part of that employee organization. In that case, the service will going to throw an exception, that is the employee is not part of that organization, that is the invalid employee. You can see that is the invalid employee. The second API, second functionality where we're going to provide the employee live capture image at working place, where we're going to verify the required protective equipment that is we have been configured for this application is head cover and face cover. So we'll go with a positive scenario. By providing this image, it has a face cover and head cover. So in that case, we're going to have, yeah, employer has over all the protective equipments. Now second case where employee has belonged to that organization, but we are providing the employee image which has a head cover but missing the face cover. So in that case, this application will going to cross verify that employer has not wear the protective equipment, but also it is listing out all the missing equipments. Once it is get listed, then it will also going to cross verify from that database whether it is belongs to that employer organization or not. Okay, so it is cross verifying that. Now that employee is found inside S3 bucket, that image is found, that cross verify from that S3 bucket, and again it is fetching the details from the RDS service. So here we can see that the employer has not wore all the required protective equipments and also missing this below detail, that is face cover. And there is a third case where the employee is not belongs to the organization, and even he is missing any one of the equipments. in that case, it will going to compare those live capture image with that stored employee details. Once it is get match, it will going to provide the employee detail whoever not wearing not wore that required protective equipments. But that employee is not belong to organization. In that case also, it will going to provide that it will going to throw an exception that that employee is not belongs to that organization, that is involved employee. So here we can see that employee has not wore the required protective equipment, and it is listing out the missing equipment. But after that, it will going to again cross verify with the employee details for that organization. That is, employee has not been captured inside the system. That is, the employee is invalid. Okay, this is all about the functionality we have been implemented by using the AWS Amazon recognition APIs, that is image analysis. Along with that, we are using two functionality, two features, that is face comparison, and second is BP detection. So this is all about the functionality, and let's look at the configuration and implementation part of this application. So here we have mentioned the minimum confidence level of that comparison. Whatever the functionality we are using for Amazon recognition, the functionality is depend on the similarity between those face comparison and object detection, that is nothing but the protective equipment detection. So here we have provided the 80% of that confidence level here. Again, we are providing the S3 bucket name, where we're going to face the images for comparing those live images, and whatever the required protective equipments. Here we have mentioned those equipments here: head cover and face cover. As we can also go with that hand cover and footwears and all. So that is the improvement. That is a part of improvement where we're going to use this applications and functionality for the other organizations. Let's take a look at the APIs. So here we have developed 2 or more APIs for supporting this two functionality. First, for verifying the employee details. Whenever we are providing any live capture image, it will going to fetch the images from the S3 bucket, and we're going to pass those images to Amazon recognition API, that is compare face. So this compare face API functionality will going to compare those two images, that is source, that is the live capture image, and the image whichever we are fetching from the S3 bucket. Then it will going to return that matches of that similarity between those images. After that, once we got an image for result of that compare face result, then we are collecting the employee ID from that image, and from that employee ID we are fetching the detail of that employee details along with working shift details. And the second API for the equipment detection. So here also we are passing the live capture image, and that image we are giving as input to the Amazon recognition protective equipment detection features. And once it is been done by that recognition API, it will going to provide us a detection equipment detection result. So in that case, we are checking with that whether we are getting those similarity between those object, whichever equipment configuration we have been done as part of application property file. Once it is get done, we'll going to have the detail detail of that object detection, that is equipment detection. Yeah, these are all the API implementation and configuration as part of these features. Thank you so much.
Yeah, thank you, Ankush, and thank you, Dhanashri. I hope we were successfully able to introduce you to these two Amazon offerings. Thank you everyone for your time and joining us here today.
Wasn't that a very insightful session, Bogdan? So much to cover and so smoothly done.
Yes, I liked it very much. I hope many of our audience feel the same. Please let us know your views in the chat window.
Well. Now let's take our audience to yet another exciting and knowledgeable session. And for this, our next presenter is Jayesh Kulkarni, who has a vast experience working in C++, using it for embedded system, IoT solutions, banking applications, and whatnot.
Indeed, Ashwad, it will be interesting to listen to the next session by Jayesh, who will describe how C++ and Rust stand against each other. Without going into much details, let us hand over to our next presenter, Jayesh Kulkarni.
Hello everyone, a warm welcome to all of you for this interesting topic, C++ versus Rust. I am Jayesh Kulkarni, currently working as an architect in Globant. At Globant, we continuously encourage one to learn new things. Rust is both new and popular. Though I'm relatively new to Rust, during my study of Rust, I realized that there are some fundamental differences between C++ and Rust. In this session, we will focus on these basic differences. This session can be viewed as how Rust appears to a C++ developer when he or she first meets Rust. This session is aimed at helping a C++ developer to quickly understand the ground for Rust features. And hence, name of the session is C++ versus Rust and not the other way around. Here is the quick agenda which we are going to cover in this session. We will not be covering all differences between C++ and Rust in the given time slot. That is simply not possible. I expect my audience to have a very basic understanding of few C++ concepts like constructor, copy constructor, destructor, and references. So let's start. Let's see what standard has to say for C++ and for Rust. C++ has a long history of having started in early 80s to latest official release of C++ 20. C++ 23 is in making. Throughout this journey, C++ kept its tag of based on the C programming language. The ISO standard says so. Now, system programming is the area of C, and hence it is for C++ as well. C++ indeed is used in many other places, considering its multi-paradigm nature, and also that it provides many facilities beyond those which are provided by C. But at the same time, it provides the performance equivalent to that of C, and hence system programming is the area for C++ for sure. Coming to Rust, Rust is relatively new, having started in 2010 or so by Mozilla. Since then, we have seen some versions being released officially by Rust community. Rust was developed to address issues faced by developers in system programming. In one interview, Rust creator Gradon Hoare said, "Rust is for frustrated C++ developer." This was echoed by Microsoft in its support to Rust. Why so? The point is, C and C++ developers face challenge, at least sometimes, in writing safe code. Rust attempts to provide that environment to write safe code. Reliability, performance, productivity are at the core of Rust. Rust documentation claims to provide these things. When it says reliability, it means memory safe and thread safe. When it says performance, it means there is no runtime or garbage collector. When it says productivity, it means it has got great support in terms of documentation and error messages. In this session, we will try to understand how Rust delivers these claims. Here on the screen, you can see two source code snippets. One is in C++, another one is in Rust. Both the programs print the same string, the same output on the console, which is test string in this case. On a high level, here we have defined a string S1 having a value test string. We have assigned S1 to S2 and we have printed S2 on a console. Simple. However, a lot of things are happening quite differently in C++ and in Rust. Let us look at these differences. Please note, we will not look at the difference in syntax. Here we have the same example with comments added for easier understanding. Differences in C++ and Rust here are very basic and important. These differences are the building blocks for understanding the difference in philosophies of C++ and Rust. Now, line 7 defines a string S1 with a value test string. But in C++, S1 is a mutable string, meaning its value can be changed at any time. Whereas in Rust, S1 is an immutable string, meaning its value cannot be changed. In C++, we can achieve this using a keyword called const. Similarly, in Rust, S1 can be made mutable by using a keyword called mute, mut. Next, on line number 10, S1 is assigned to S2 in both C++ and Rust. But a different magic is happening in both the programs. In C++, a copy constructor is called and S2 is created. Hence, S2 is a copy of S1. So, the result is both S1 and S2 are valid and different objects, independent objects after assignment in C++. In Rust, assignment is not a copy. Default behavior is move, destructive move, meaning S1 is moved into S2 and S1 is no longer valid, no longer useful after assignment. Now, this is a very basic difference in default behavior, copy versus move. In Rust, we do have specialized functions like copy, which can give us a copy of a particular object. In C++, we do have move semantics, which can move that particular object into another object. But even after the move operation, in C++, in this particular case, S1 will be an empty, valid, independent string even after the move operation. That is not the case for Rust. Here, Rust is quite restrictive, and if you want to do something more, then you need to use additional keywords, specialized functions. Similarly, in C++, if you want to impose the restrictions, then you need to use additional keyword and specialized functions. Point to note for Rust further is, while passing a parameter to a function, the parameter is moved into that function. Hence, the parameter is no longer useful in the calling function. This is because the ownership is being transferred. To avoid this, one needs to explicitly pass a copy or a reference of a parameter to a function. This way, a developer will have to cautiously decide how these parameters, variables, are going to be used, referred, and owned. Rust flags an error if these are not being handled in Rust way. Consider passing an argument to a function in C++. There are three ways: pass by value, pass by pointer, pass by reference. Default is pass by value. C++ tries to create a copy and move ahead, and that sometimes causes an issue like shallow copy if one is not enough careful. Point to note, on line number 10, deep copy is used. Rust makes it simple. More the restrictions, safer the code. So here is the first concept of ownership in Rust, which we are seeing. At any given time, there can be only one owner associated with a value. Let's move ahead. Here is what we have learned. Everything is movable. Default is the move operation in Rust, and by value operation on all types except the basic ones like integer are destructive move. Let's move ahead. In Rust, transfer of ownership, that is move, happens in three cases: assigning a value, passing a value to a function, returning a value from a function. This is quite inconvenient. For this, Rust supports a concept of borrowing. This is similar to references in C++. Well, not exactly similar though. Let's dig out further. In this sample code, I is a mutable integer having value 5 in both Rust and C++ code snippet. nref on line number 7 is a mutable reference, that's a borrow of I. On line number 8, ref1 is an immutable reference or a borrow of the variable I. Line number 9 prints the value of the variable using mutable reference mref on the console. Overall, simple stuff. C++ program rightly prints a number 5 on console, and Rust program fails to compile. Oh, wait, what? Rust program does not compile. Let's see why so. Rust wants to prevent data races. A data race means a situation where one thread is trying to write and another thread is trying to read data from a common data, shared data, in an unsynchronized way. So in this example, here is the situation. Mutable reference mref and immutable reference ref1 coexist. Mutable reference might change a value of a variable. This can cause a problem in source code, which is using immutable reference, which is relying on the value of that immutable reference, assuming the value won't change. Hence, Rust does not allow mutable reference and immutable reference at the same time. Rust allows only one mutable reference at a given time to avoid data races. Multiple immutable references are allowed, as these will be reading values from the common data and will not be changing the value. This is the Rust philosophy of borrowing. A bonus point. Look at the error message. Notice the error message over here. It is showing exactly where the mutable borrow, that's the reference, is occurring first, where the immutable reference is defined, and how these references are causing the issues, at which line number. The error message is pretty clean, neat, direct, friendly, and easy to understand. That's one of the goals of Rust, to deliver on the promise of productivity. These error messages do increase the productivity of developers. Notice that in C++, understanding where the error is, what the error is, takes some time. And sometimes it takes a good amount of Googling to figure out the solution. That's not the case with Rust. Here is what we learned. Borrowing and ownership together, these two concepts together form a good base for safe programming in Rust. Let us understand these with few more examples. Here is a simple example to show how Rust detects the error at compile time and highlights those. Note that I have just included Rust code and not the C++ code. So here is the Rust program. On line number 3, we have defined a vector v1. Line number 4, we have defined an immutable reference to one of the elements within the vector. Line number 5 clears the vector. Line 6 is attempting to print the value using the immutable reference defined on line 4. Rust did not like it, and it failed to compile the program. Rust rightly found the error. References to an element within a cleared vector will not work. It will give some runtime error, and Rust wants to avoid it. It detects it at compile time using the concepts of borrow, ownership, mutability, and immutability. Let's check another example. Here is a classic one. This is an example of a pointer to a local variable which is out of scope. Rust compiler showed the error here as well. So here we have this local scope having the variable I. Reference that's the pointer defined outside that local scope, and it is assigned on line number 6 to a local variable. Line 7 and line 9 are trying to print the value of a variable using the reference, using the borrow. Here, the variable I is out of scope, and Rust rightly identified this and shown the error. Note that C++ compilers will not complain in such cases. However, such scenarios cause an issue during runtime. Rust, using its rules of ownership and borrowing, finds such issues at compile time itself. Invalid references, dangling pointers are not allowed in Rust. So now we have come to understand how Rust is using the building blocks to deliver on its promise of reliability in memory-safe way. Let's see how Rust claim on safety works in multi-threading example. Let's see how Rust works when there are multiple threads. Please note, multi-threading in itself is a big topic. We will briefly look at one aspect of it. This is a thread counting example. Number of threads are created. A counter is incremented in each thread. At the end, we get how many threads are there once all threads have executed. Rust code is taken from official Rust documentation. I have just separated out the thread function for easier understanding. C++ code is an equivalent of the Rust example. Lines 11 to 14 represent the thread function where we are trying to increment the counter. Lines 20 to 25 are trying to create 10 threads in a for loop. Lines 27 to 29 wait for execution of all threads to get executed. Line number 31 is printing the value of the counter at the end of the execution. We created 10 threads, hence the result is 10 for both the programs. Let's look at the use of mutex in C++ and in Rust. In C++, on line number 17 and 18, we have defined mutex and shared data. Note that in C++, mutex and data are two different things. Mutex is used to protect the critical section. A critical section is the code segment where multiple threads access shared data. Atomic action is required in critical section, and for this, mutex is used. In Rust, we have single line wherein on line number 17, which is defining the shared data, but we need mutex to define the shared data. Meaning, without mutex, one cannot access data. Let's understand this with the help of thread function. On line number 12 in C++, we need to acquire the mutex and then we can increment the counter. On line number 12 in Rust, we need to get access to the counter function and to the counter variable, and then we can increment it on line number 13. We can forget to acquire the mutex in C++ on line number 12. Rust will not allow us to miss line number 12. Threading is an important and complex part of development. One needs to be careful while implementing multi-threading scenarios. A small mistake can lead to a number of tricky issues at runtime. Rust tries its level best to provide the constructs in a way to eliminate the errors which programmers can make. For example, forgetting a mutex is not possible in Rust. Using a simple variable without synchronization mechanism is also not possible due to ownership, mutable reference, lifetime rules in Rust. For all these errors, Rust code will fail to compile. If code compiles in Rust, then chances of runtime issues are very less. ARC, atomic reference counting, is a big topic in itself. We will not go deep dive into it. Just note that this code will not compile without the use of ARC. The lifetime rules of Rust enforce us to use ARC mechanism. So here is the final summary of this session. We saw few concepts, the basic building blocks of Rust. We saw ownership, borrowing, compile time check of references, pointers, and use of mutexes. We tried to understand how these concepts are different from the ones in C++. All these features enforce a developer to write less error-prone code. Many errors are captured at compile time in Rust. This results in safer code in terms of memory and concurrency. Thus, Rust delivers a promise of reliability. For C++ developers, these things come with experience. Static code analyzers and compilers do help, but Rust makes it more straightforward and much easier. For the performance promise, Rust does not have garbage collector. Performance benchmark show that Rust's performance is comparable with that of C and C++. And hence, many companies are considering Rust for development of its core components. For the productivity promise, we saw the error message that Rust compiler shows. Those are pretty good. Rust official documentation is also very nice. The community support is gaining momentum in Rust. It is not as big as C++, but it's good. There are many features which we have not yet covered and we will not be able to cover in this session. The objective of this session was to understand how Rust and C++ behave in a certain scenario at a basic level. This understanding will further help to build on the Rust knowledge. Here is a list of features in Rust which we could not cover. Cargo. Cargo is the Rust's package manager. It downloads Rust packages dependencies, compiles the packages, and so on. In C++, we do not have any package manager as such. Official package manager, we have some packages like NuGet, which are specific to Microsoft Windows. Crate is similar to a package. For example, it can be considered as a module in C++20. Crates.io is an official crate that is a package registry. In C++, we do not have anything equivalent of this at the moment. String in Rust is a big topic in itself. Strings are UTF-8 by default in Rust. Generics are similar to templates in C++. Traits can be considered as interfaces. Of course, these two features have their own Rust flavors. Lifetime rule and annotations are something which help define the scope of a variable for the parameter which is passed in a function in Rust. Enum in Rust is quite different from C++. Enum in Rust is a mix of enum and union in C++. Pattern matching is a big topic and on a very high level can be considered as similar to switch case in C++. Error handling, smart pointer, threading, unsafe code, and syntax in itself. All these topics are detailed in Rust official documentation, and these are pretty good. Please note, Rust has its own learning curve. It takes a while to understand the principles and master all these concepts. Finally, it is not about a winner. That's not possible, or that's not possible at least yet. The scope of C++ applicability is vast. Newer versions of C++ are adding quite a lot of new features, and while doing so, the backward compatibility is maintained. In the preface of the C++ programming language 4th edition book, Björn Strostrup, the C++ creator, says, C++11 feels as a new language. It is better than earlier versions. If you stick to older style, you will end up writing low quality code. Well, that's correct for every new version of C++. Maintaining backward compatibility for 30 plus years of legacy, millions of lines of existing code is simply incredible, and C++ has done this. Luckily, Rust does not have any burden as yet. Rust does focus on system programming. However, it also claims to be a multi-paradigm language similar to C++. So, surely Rust will flourish and C++ will not go away. On this note, we will stop here. Thank you very much for your time. Have a great day. Thank you.
We had 2 amazing days full of interesting sessions. Hopefully you guys enjoyed this as much as we did. We look forward to seeing you at our events next year. For the closure of this insightful event, SCNXT 2021, we would like to invite Daniel, the leader of Scalable Platform Studio, to give the final remarks.
Hi, my name is Daniel Murad. I'm the VP of Technology and a studio partner of Scalable Platform Studio. First of all, I want to give my thanks for joining this event. During these 2 days, we showed several cases of many challenges that we have in our current world. Also, we went through many upcoming technologies and trends, where these things are changing the way of how we build solutions. Applying AI, composite architectures, different accelerators such as no-code tools in order to improve the experience of our customers and also of our experience on how we build products. Being more inclusive and diversity between us and with our environments. We are living at a time in which technology change, new devices, sometimes appears overnight. At the same time, climate change has become a reality, affecting everything we do. What is the role of Globant playing in this landscape? Globant is and has always been a company focused on reinvention. Reinvention is in our DNA. It's what we do. It's why we exist. We believe that the success of any company is rooted in its availability to reinvent itself. Through our 18 years history, we have been focused on reinventing ourselves and the companies we work with. We started focusing on reinventing the professional service arena, enabling delivery at the scale. Then we moved on creating experiences that we went beyond digital, creating compelling experiences that transform your day-to-day. We have been at the forefront of every era of digital transformations. And now we are thinking about reinventing industries and leading market reinvention. We are constantly thinking about how to reinvent ourselves and our clients. Why and how we design profound transformation that go beyond digital. We prepare our clients for the future. We provide services and solutions that allow them to take back control and stand up on their own. We blend engineering, innovation, and design with a unique approach that enables business reinvention. Every piece of software is built to meet a business need, but those needs are not static. They are subject to change. New trends and technologies arise every day. Customer behaviors and business goals change, and those softwares need to adapt and evolve as well. In this scenario, it's critical to build a technology platform that fulfills today's needs, but also needs to be able to evolve and adapt for future changes. Our Scalable Platform Studio provides a proven path to strategies, build and evolve digital platforms that set the foundational backbone to underpin the client business transformation. We serve companies that are looking to enable digital products through a robust and future-proof architecture. To meet this goal, we have 3 big practices with several offerings included inside. From our strategic architecture consulting, using our capacity to help on digital transformations, adopting new technologies, creating awesome enterprise architectures, setting up center of excellence models, migrating legacy platforms to the cloud, and many, many others. On the other hand, augmenting composite solutions, where we apply software democratization solutions using, for example, low code, AI, or different accelerators, also cloud fitness, microservices, and API adoptions, and many others. And last but not least, platform evolution, where we have models in order to avoid the obsolescence of our products and the ability to evolve, support, and modernize them. Concluding this event, guys, I'm hoping you have enjoyed it, and again, giving my thanks to the whole team who has worked very hard to bring us the latest updates in technology and business, and looking forward to seeing you again in the coming Scalable Platform Next sessions next year. And as we say in Globant, be kind with your peers, be kind with yourself, be kind to the planet. Thank you so much, take care, and see you around. Bye.
Thank you, Daniel. It was a pleasure having you on board, and we also are looking forward to further SCNXT events.
And for our wonderful audience, we would say, don't go yet. We have something more for you all. Any guesses what it is? Yes, it is the time for that quiz that we have been mentioning on to the 2 days.
To participate in the quiz, you'll have to copy the link given in the description and join into the Zoom meeting mentioning your full name. So do participate in the quiz for some exciting vouchers.
And yeah, there is a catch. Only people who had registered for SCNXT 2021 conference will be eligible as a winner. So if you have still not registered, please do so. And once you are done in approx 3 to 5 minutes of time, hop in onto the Zoom call where we will be waiting for you with the quiz.